أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم.
CB-SEM using SmartPLS4. Now that SmartPLS4 has provided the option to perform covariance-based SEM, I'm going to start a new series covering the basics and advanced features of CB-SEM using SmartPLS4. Now, what will be the contents of this whole series? The series will cover an introduction to SEM, measurement and structural model, basic measurement model, SmartPLS output, improving model fit, assessing reliability and validity, basic structural model, reporting measurement and structural model, mediation analysis, reporting mediation analysis, moderation analysis, reporting moderation analysis, and finally the higher order construct analysis. Let's assume you have done your research and you have written the introduction, you have done the literature review, you have collected the data for, let's assume this is the model for which you have done it. Now, this is quite a complex model in which you've got, let's say, an antecedent or two of the antecedents that are affecting KM processes. KM processes is affecting organizational performance indirectly through creative organizational learning. Now, such model cannot be analyzed using SPSS because SPSS does not allow you to have multiple dependent variables or multiple mediators or serial mediation, although you can do mediation using Hayes process macro, but this model as a whole cannot be analyzed using SPSS. For such models, we go for structural equation modeling. Now, in that case, you've got different options. You can go for variance-based SEM using SmartPLS, and now with this new feature, you can go for covariance-based SEM using structural equation modeling using SmartPLS. Now, for this whole series, although variance-based SEM, how to use it, how to do detailed analysis, complex analysis, and the whole playlist is available on the channel, and the link will be shared in the description. Now, before we move on and understand how will we go about analyzing such models, let's say I've got a sample questionnaire as well. So I'm just going to show you, let's say every single questionnaire that we have will have these constructs and items will be used to measure these constructs. Now, a sample questionnaire comprises, or in this case, a questionnaire comprises of constructs and items corresponding to each of the construct. A construct is measured using a number of different items. If a scholar intends to use SCM for data analysis, it is strongly recommended that each construct be measured using at least 4 to 6 items, since in SCM items do get deleted. So let me show you a sample questionnaire. Now here is the sample questionnaire. So I've got a construct organizational learning and 8 items to measure organizational learning. Then I've got organizational culture and 6 items to measure organizational culture. Similarly, I've got other constructs and items to measure those constructs in my study. Now, moving on. Let's say I want to study this kind of model. So what CB-SEM or VB-SEM or SEM based tool gives you the liberty to is to model complex relationships. So I've got these constructs measured using these items. These constructs are lower order constructs, service quality is a higher order construct, and it is affecting satisfaction. Satisfaction is affecting behavioral intention, so satisfaction is a mediator. Now, before you go on and start studying SEM, you should understand what mediators, moderators are. Otherwise, you will have trouble understanding the concepts that we go through. So, such complex models can be easily performed, analyzed using SEM tools. In this case, SmartPLS4. So, what is structural equation modeling? Structural equation modeling, or SEM, is a statistical method that examines the relationship among numerous variables in a simultaneous way. Now, SEM is not considered a single procedure, but rather a family of related statistical techniques. The family of analysis techniques examines the measurement properties of the variable, and that is, they look into the reliability and validity of the construct, and the interrelationship between variables, and is often seen as a combination of regression and factor analysis. So SEM is normally a combination of factor and regression analysis. The use of SEM will often take a confirmatory approach in which the researcher has proposed a model of relationship between variables of interest and examines whether the observed data will provide evidence of directionality and significance of relationship. So what you're doing is you're looking at how well your data fits your model. SEM is very similar to multiple regression, but is much more robust and has a greater flexibility in the analysis. SEM allows you to model multiple independent and dependent variables, error terms, interactions, and correlations. So simultaneously, you are performing multiple analytical techniques. Using a SEM model will also let you denote which independent variables will influence dependent variables, and subsequently let dependent variables be independent variables in other relationships. So you can have mediators, moderators, IBs, DVs, control, all in the same model. Now, structural equation modeling is fundamentally built around the idea of modeling or drawing a model that represents a relationship between variables. This model will use symbols to represent variables, relationship between variables, and even error in your model. So you will have symbols to link variables, represent variables. Now, SEM begins with a theory where researcher intends to test the relationship among constructs of interest in the study. So you have a theory that these variables are related with each other. Then you collect the data and SEM will test or help you test that theory. The relationships are modeled in a theoretical framework represented by a schematic diagram, the one that we represent, or the one that we saw earlier. The schematic diagram presents the hypothesis of interest, so which variable is influencing which variable. So then you can have direct hypothesis, indirect hypothesis, moderation hypothesis as well. Now I've got a video on hypothesis and I'll share it in the description. Now the constructs of interest involved are measured using a set of items in a questionnaire that we just saw. The measurement scale for each item should be interval or ratio. Now if you are to use structural equation modeling, your items, your variables should be measured on metric scale or interval or ratio scale. Now structural equation modeling typically involves the assessment of two models, that is measurement model and structural model. Now what are the advantages? It lets you analyze the influence of predictor variables on numerous dependent variables simultaneously, which is not the case in SPSS. It allows you to account for measurement error and even addresses errors in predicting relationships. And it can test an entire model instead of just focusing on individual relationships. That is, you can have direct, indirect, moderation, mediation, control variables all in the same model. Now this is a sample measurement model because SEM or structural equation modeling will have two submodels, measurement model. Now confirmatory factor analysis is a statistical technique that analyzes how well your indicators, now these are your indicators, OP1 to OP4, CC1 to CC6, they measure the unobserved construct. Now how well these items are measuring these constructs, the blue ones. And if your unobserved construct, that is these blue ones, are uniquely different from one another, that is they have discriminant validity. Now the first step in SEM using smart PLS is to draw a measurement model for confirmatory factor analysis. So you draw your measurement model to establish confirmatory factor analysis. Now all the constructs in the study are drawn and then covariated with each other to perform CFA. Now this is covariance. Now we are going to look into this in detail. This is just an introductory session. Then the model is assessed for model fit, reliability, and validity. Moving on, structural model. Now this is the structural model. Look at the arrows now. They are not double-headed arrows. Now one variable is influencing other variable. Now this is a higher order construct, is influencing satisfaction. Satisfaction is influencing behavioral intention. These are the structural relationships. Now we are going to look into this in detail as well. Now, once the measurement model is assessed and the assessment is complete, the next step is the structural model assessment that refers to testing significance of hypothesized paths. So what relationships you have presented as part of your literature review, you are going to test in structural model assessment. Now, some key terminologies. Constructs, they measure theoretical concepts that are abstract, complex, and cannot be directly observed by means of multiple items. Constructs are represented in path models as circles, the blue ones that we saw, or ovals, and are also referred to as latent variables. Now, indicators, these are directly measured observations, manifest variables, raw data, also referred to as either items or manifest variables, which are represented in path models as rectangles, the yellow ones. They are also available data, that is the responses to survey questions or collected from company databases used in measurement model to measure latent variables. Now, the items that we refer or that we ask questions. Now, factor loadings, the bivariate correlation between a construct and the indicators, they determine an item's absolute contribution to its assigned construct, how well a particular item is measuring the underlying construct. Loadings are of primary interest in the evaluation of reflective measurement models, but are also interpreted when formative measures are involved. Now, latent variables, elements of a structural model that are used to represent theoretical concepts in statistical model. A latent variable that only explains other latent variable on the outgoing relationship in the structural model is called exogenous. So a variable that is influencing the other variable and is explaining the variance in the other variable is exogenous variable. While latent variable with at least one incoming relationship, so an arrow pointing from one variable to the other variable, is called endogenous variable. So if an arrow, let's have a look here. So in this case, service quality here is an exogenous variable. No arrow is pointing towards service quality. Whereas satisfaction is an endogenous variable, but it is also an exogenous variable because an arrow is pointing towards it, but then an arrow is pointing from satisfaction to behavioral intentions as well. Now, T statistics. Now, this is the cutoff criteria on which the significance of a coefficient is determined. Now, whether your relationship is significant or not is determined based on T statistic. Now, if it is above a certain threshold, you can say the relationship is significant. So this was the first lecture on an introduction to SEM. Following this, I will have another brief theoretical session on the concepts related to structural equation modeling, and then we will have practical sessions on how to use smart PLS for CB-SEM. Thank you very much.